Pavan?
Good afternoon. I know it's been an extended session, so I'll try and keep it short. And also very different from all the other presentations that you saw here. Can I have my PPT up there? Yeah, thank you. So there are two examples I just want to take you through. Excuse me, I'm not Spanish speaking. If I get some of the words wrong, please excuse me on that. The Sagrada Familia in Barcelona. I don't know how many of you have been there and seen it. I'm going to take a little story on that and talk about how nature is the best inspiration for any kind of product design. I think the most efficient system in the world is designed by God and nature. Take ourselves. How optimized are we? That's the example I want to talk you through. Of course, since it's also a session on energy, which nobody else spoke about, I have an example which is the complete diametric opposite of a nuclear power plant. So I'll take you through both those examples. Some snippets of information. Still under construction, 100 plus years. Still going on. It's a huge effort. And I don't think they'll ever do the 18 towers that was planned. I believe it will stop at 8. So that's where we are. It's 170 meters tall, 1 meter short of the mountain range around the city. Still, Gaudi believed that God's creation should be taller than what he can create. So it's a 1 meter shorter than the mountain range there. Now, this is the story of the whole cathedral, as narrated by one of the architects.
And I'm an architect for the office of the Sagrada Familia, and we are just making the continuation of the construction of the building. So we kind of focus in the study of the original parts that Gaudi had already constructed. And we also analyze all the plastic models and the drawings and the writings that have been published of his works. So we try to apply all these concepts and knowledge to the current construction. And so we are trying to make this kind of fit between this 100 years old project to the current top-notch technology, using also the most advanced software and also the construction technology. We try to apply just the best technology we can. Gaudi used nature as a result to his project, but he tried to not merely look at nature, but to understand how nature was working and behavior. So he always wanted his solution to have also the aesthetics, the construction and the structure to work as a whole. So everything has to have a purpose, a meaning, and a function. If you have had a look to the wire models for the Colonia Way Church, you can see how he defined this model where there are some wires hanging from the roof, and in each of these wires he put a sandbag, which represents the actual weight of the building. And so this way he's getting a geometry which is working only in tension. And when you put this geometry upside down, you're getting just a geometry that's adapting to a force which is only in compression, which is just the best way to work for a stone masonry. So this is how Gaudi was trying to apply this concept, which is a concept that it's present in nature, is that the living being is trying to adapt to its external influences. And so with this, he defined the geometry, and this is the way he get this kind of forest, which is in the interior of the Sagrada Familia. And so this is how you get to the interior and you feel this kind of comfortable space where nature is just embracing you in order to have a quiet place to pray and to meditate. It's how usually it works, that the architect is making the model and the aspects of the project, and then when it's all defined, he will bring that to another team, and this team will just make a check if everything is working, and if it's not working, they will say, well, this needs to be bigger or needs to be, and you kind of have this kind of separated minds that are not really working together, but just telling the other one if what they're doing is working okay or not. And if we try to just merge them in the start of the project, we will get to new forms and new solutions, which I think it's really what this kind of software can produce, and will get us to solutions that are more natural looking and more interesting and evidently more efficient.
Thank you. Needless to say, that was done using some pieces of software that we make. We are a CAE company, a finite element analysis company, and we have 3 business lines that we want to bring together to achieve sustainable solutions like what you saw here. We have the simulation, the high-performance computing, and the AI and data analytics practice pulled together. So we have product sets which cover all of it, and that's what we hope we'd call it rocket science and bring it all together. We're a fairly large outfit across the world. I'll skip through these slides, pretty diverse. The fact that I run worldwide sales but sit in India tells you about a little bit of diversity. And of course, spread across, and customers in various segments. We have customers right across the space. Having said this, I just want to take you through one more product journey, now shifting into engineering or more product design. Take any product that you have, whether it be a cycle or a motorcycle or whatever, you go through several phases of the journey, right from the concept design down to this recycling piece of the equipment. Recycling was not important in the past, but as you heard from several of the speakers today, super critical at this stage. And one thing that goes around all of it is the digital thread that connects it all. So this connection is what we enable using the 3 enabling technologies that I spoke about, the convergence of simulation, data analytics, and high-performance computing. Again, a different view of the same thing. I won't go through this slide, but I promised to talk about the digital twin of a nuclear power plant, where we brought together all these 3 aspects and how a customer of ours has actually been applying this. It's a company in UK.
Assystem is an engineering and digital services company, and we work in the decarbonisation industry. We have been essentially in that industry since 1966. The digital twin project that we worked on with UK AEA was to see whether it was feasible to hook in structural integrity calculation models into a live data stream from a plant. And the reason why that was of interest to us is there's a lot of structural integrity calculations are necessary to be done during the design of the plant to make sure it's durable and it's going to last the lifetime that it's meant to last. And what tends to happen is once you get into operation or into production, those models are no longer used. They're effectively lost. So what we wanted to know was whether we can turn them into a true digital twin. So whether we could take those calculation models, which are digital representations of the real plant, and instead of feeding them with the design basis loading, which is a pessimistic load case, we can actually start feeding them with a real data stream from the actual operating plant. And to do that, we essentially needed a means by which we could connect the 2 together to provide that backbone. And Altair SmartWorks was the key enabler to allow us to do that, because it could store the input data, it could feed that input data to our calculation models in a batch mode, say an hour at a time. Our calculation models can then process that into useful information, and that would be what we call virtual gauges or virtual sensors. So that's providing information that you can't actually instrument on the plant, either for access reasons or just the environment is too severe. Obviously, what we would also want to do is to be able to visualize that information. Panopticon gives great flexibility for how you can visualize that data. So we can condense it down to just a summary number or a gauge for essentially fatigue usage factor or remaining useful life in years or time to next inspection. All of these things can be visualized within Panopticon, and it's pretty straightforward to set up. Once you've got all of your models hooked up and available, you don't have to feed it with historical data. You can spawn, copy that entire plant digitally and feed into it synthetic data of how you might want to operate that plant in the future.
So that was about the two extreme ends of the examples that I could think of. One nature-inspired, one something that we are stuck with. Nuclear power is not the best solution. All of us know that, but it is environmentally friendly when it's running well. Zero CO2 emissions, so on and so forth. But how can we enable and use technology to not just drive the system, but also have a more sustainable future across both these asset classes? Thank you very much.